Hi everyone, I thought I'd put together a bit of an informational video on ballistics and why it's important to understand for shooting, especially when it comes to long range. There is a lot more that goes into it than what I'm going to be talking about, but welcome to the Basics of Ballistics. Ballistics is the science of projectiles, especially in firearms. In this video I'm going to be talking about the very basic science behind it, internal and external factors that affect it, and towards the end a talk-through on how to use ballistic apps and ballistic data to calculate trajectory, which in turn will give you your elevation and windage adjustments. We'll need to know some things before we start, so here's the terminology. 0. This is where your point of impact is the same as your point of aim. For all following examples, your 0 will be 100 yards. Ballistic Coefficient, or BC. BC is a measure of a projectile's ability to overcome air resistance during flight. A higher BC indicates the projectile experiences less drag and maintains velocity and accuracy over longer distances. Essentially, it quantifies how efficient the bullet is. MOA and mil. These are both angular units of measurements used by shooters to determine scope adjustments, shot placements, and shot groupings. More on this later. Velocity, a projectile speed measured in feet per second. Supersonic, something that is faster than the speed of sound, which is roughly 1,100 feet per second. Subsonic, something that is slower than the speed of sound. Transonic, this is when a projectile transfers from supersonic to subsonic whilst in flight. Standard deviation, or SD. Standard deviation is a statistical measurement that quantifies the amount of variance or dispersion of a set of data values relative to its average or mean. Extreme spread, or ES, another statistical measurement that denotes the highest and lowest data points in a set of values. Ammunition. Ammunition has 4 components: the primer, the case, the propellant or powder, and the bullet itself. Each of these components will affect the velocity and energy output of the bullet when it leaves the barrel. The primer will start the ignition of the powder, which will burn back to front, creating very high pressured gas. The expansion of this gas is what pushes the bullet down the barrel and out the muzzle. How the ammunition is loaded, different charge weights and seating depth and such will affect the muzzle velocity of the bullet and how accurate the rounds will be. The barrel. The barrel will also majorly affect how the bullet flies. The barrel is 95% of the accuracy of the gun, so it's vital you have the correct barrel for long-range application. There are 2 major barrel features that will affect the bullet: the twist rate of the rifling and the length of the barrel. For those who don't know, rifling is the spiraled grooves in the barrel which spin the bullet whilst it travels through. The spinning action is what stabilizes the bullet in flight, the same way a rugby player will spin a ball when it's thrown. The twist rate of a barrel is measured in a ratio. For example, a 1 in 8 twist barrel will have 1 full rotation of rifling for every 8 inches of barrel. Therefore, a 24-inch 1 in 8 twist barrel will spin the bullet 3 full times before it leaves the barrel. That same length barrel with a 1 in 12 twist will spin the bullet 2 full times before it leaves the barrel. With that in mind, a faster twist rate barrel will have a lower number. Typically, for long-range target shooting, you will want a barrel with a faster twist. This will help stabilize the heavier target-oriented bullets. This doesn't necessarily mean that the faster the twist the better, as if the twist is too fast, it can lead to bullet instability and jacket/core separation. On the other hand, if the twist is too slow, it won't stabilize the bullet correctly. The barrel length will also affect the bullet before it leaves. A longer barrel will give the expanding gases from the burning powder more time to push the bullet. This will result in a higher muzzle velocity, thus leading to a flatter trajectory and less bullet drop over a distance. The longer the barrel, the more the twist rate will affect the bullet as well, stabilizing it further. A longer barrel also means a slight increase in overall weight for the rifle, which will reduce the amount of felt recoil by the shooter. Very generally speaking, you will gain or lose 25 feet per second of velocity per inch of barrel. The bullet. Bear with me on this one, it might get a bit nerdy. The bullet itself, being the thing that actually flies through the air, has a surprising amount of technology behind it. The main 2 factors I'll be talking about are bullet weight and ogive profile. Bullet weight selection is important when considering ballistic performance. Generally, a heavier bullet in any particular caliber category will be better than a lighter bullet going at the same speed. Heavier bullets are usually longer and more streamlined, which will contribute to retaining velocity over longer distances and resisting wind drift. Heavier bullets will also have a higher ballistic coefficient. This will help in a more stable flight downrange and be more predictable at longer distances. Most target-oriented bullets are BTHP bullets. BTHP stands for boat tail hollow points, which describes the shape and characteristics of the bullet. The boat tail being the back of the bullet, which looks like the back of a boat from the top down, and the hollow point referring to the tiny hole in the front of the bullet. Both contribute towards better ballistic performance in their own way. The ogive of the bullet is the curved portion of the bullet between the tip and the full diameter body or the bearing surface of the bullet. bullet ogive influences ballistic coefficient, drag characteristics, and seating depth sensitivity. The two most common types of ogive profiles are secant and tangent ogives. A secant ogive is a sharper, more tapered curve. This generally leads to higher ballistic coefficient, less drag, and better long-range performance. The disadvantage of this profile is that it can be more sensitive to seating depth. The seating depth of the bullet is how far into the neck of the case it is. The profile is used in many match-grade bullets like the Berger VLDs and the Hornady ELD match bullets. A tangent ogive is a smoother, more gradual transition from tip to body. This profile is more forgiving of seating depth variations and is generally easier to tune for consistent accuracy. The disadvantage is that there is a slight loss in ballistic coefficient when compared to a secant ogive. The world-famous Sierra Match Kings use a tangent ogive. Some newer target bullets are using a hybrid ogive profile. This combines both the characteristics from a tangent and a secant ogive. The advantage of this is that it gives you a higher ballistic coefficient whilst also being quite forgiving when it comes to seating depth. The disadvantage of these is that they are more complex to manufacture and therefore more expensive. Berger hybrid bullets are highly regarded as the best target shooting bullets on the planet. In the real world, 99% of shooters won't be able to tell the difference downrange. If you're not hand loading your own ammunition, you won't have many options when it comes to fine tuning anyways, so just buy some different brands of ammunition and shoot what works best for you. You've heard me talk about ballistic coefficient and how it's pretty much just how efficient the bullet is. BC can vary depending on the velocity of the projectile, and like ogive profiles, there are also different BC profiles. There are three main profiles that people use in target shooting: G1, G7, and CDM. A G1 profile is based on old flat-based higher drag bullets. This is an old outdated BC profile and isn't ideal for calculating ballistics in modern bullets. A G7 profile is based on boat tail low drag bullets and is more accurate when calculating trajectory for modern target shooters. A G7 BC will stay more consistent across different velocities when compared to G1. CDM, or custom drag model, uses Doppler radar data to model the actual drag of a specific bullet at all velocities downrange. This is the most accurate way to model a flight over using a G1 or a G7 standard. The Hornady Fordhoff and Applied Ballistics apps both use a CDM with specific bullet profiles. Like with bullet profiles, most people probably won't even notice the difference. The better ballistic coefficient profile will give you a more accurate result, but in the real world, as long as you've got some data, it's better than none. When you're shooting at smaller targets at further distances, the BC profile does matter a lot more. External factors. There are many external factors that will change the flight of the bullet once it's left the barrel. I won't be explaining every single one of them because we'll be here for hours, but to name a few, there is gravity, temperature, humidity, air pressure, air resistance, drag, wind drift, spin drift, the Coriolis effect, and many more. The initial velocity, ballistic coefficient, twist rate, and weight of the bullet, combined with all external factors plugged into a ballistic calculator, is what gives us our elevation and windage readings. Ballistic calculators. There are many different ballistic calculators out there, but I'm going to be showing you AB Quantum and the Hornady app. I'll be showing you how to obtain the data to input into the calculators to give you the data that you need to adjust your scopes. This is the home screen from the Hornady app. Click on BC to open the ballistic calculator. Click on favorites, and here you can add a profile, so you can build different profiles for different rifles. The title, the rifle, and the optics fields can be pretty much anything, but the bullets/ammo field is where you'll be putting in your bullets. So listed here are all the bullets that Hornady make, and it's automatically got the ballistic coefficient of all of the bullets listed. So I'm going to choose the 75 grain ELD match bullets, and here I'm going to enter my rifle statistics. So I'm going to put 2750 feet per second as the velocity, the zero range will be 100, the sight height will be 2.25, the barrel twist is a 1 in 8, and the windage offset you don't need to worry about. In this section, if you're home loading, you can also write down your home loads so you know what you're shooting through what gun. Now if you click on it, you'll be presented with this screen. This is the main screen for the app. This bit that I'm adjusting here is the wind direction, so you can choose which direction the wind's coming, and just above that is the wind speed, so it can go from 0 all the way up to I think 50 miles an hour. On the left hand side there's a slider where you can enter your distance, or if you click on the number you can enter it manually, so you can do big jumps from 100 to 200 or 1000 or whatever you're shooting at. And as I'm changing them here, if you look at the bottom you can see the come up and the windage changing. So at 600 yards, the come up for this specific rifle is 14.5 MOA. And like I said, if you want to slide it up and down to get a more accurate result, you can do that as well. If you click on edit variables here, you can see all of the external variables I was talking about earlier. So shooting angle and altitude, if you're shooting uphill, downhill, maybe if you're shooting high altitude or low altitude. Air pressure is quite important, and temperature and humidity as well. It could be quite humid in the UK sometimes, so humidity can have quite a big effect on ballistics. And here you can change the custom units as well, so if you use imperial or metric, it'll work for both. So a very simple app to use. Once you get the hang of it, it makes a lot more sense. You can build out lots of profiles, so if you've got multiple caliber guns or you shoot different ammo through different guns, you can just quickly load up the profile and you'll be able to easily see your adjustments from there. The AB Quantum app by Applied Ballistics is a lot more feature rich. It'll give you a lot more information and a more detailed view about your ballistics. I'm not going to go over every feature in this app, as again we'd be here for hours, but I'll show you basically how it works. This is the screen you'll see when you boot up the app. As you can see, there's the elevation, the windage, the lead and the windage 2 right at the top of the screen. There's the range just below that, and just below that there's the reticle and the WES. I'll get into those in a little bit. Just below that is the environmental factors, the temperature, humidity, pressure, latitude and density of the air. Just below those there are the little icons for the Wi-Fi symbol. If you have a compatible device like a Kestrel for example, you can link that with the app, which will automatically update these fields when the weather changes. If you click on the reticle tab, it will show you the reticle that you've got set on your scope. Click on the WES tab, it will show you this graph depending on the graph that you've selected, which is basically a hit probability calculator. And here, just like the Hornady app, you can change the temperature, humidity and everything else. And as you'll notice, this will give you a change in your elevation. At the bottom, if you select target, this is where you'll be putting in your target information. So the speed at the target, the speed at the firing point. You can put in two different selections of speed. So if you've got a wind speed reader at the firing point and one downrange, you can put both in and it will give you a more accurate elevation and windage adjustment. The WES calculator, like I said before, is basically a hit probability calculator. You can put all of the data in the fields here and it will give you a likely percentage chance that you'll hit the target. This is more important for shooting steels or other objects and not paper. And here, if I change the range from 600 yards to 1000 yards, the hit probability will go from 73% down to 12%. If you click on graphs and select all these different options, it will give you lots of different graphs for lots of information. I'm not going to go into that now because it'll be too much for this short video, but maybe I'll do it in the future. Here you can see the different profiles I've got in the app. These are all of my personal rifles, so I've got a 223, a 6.5 Creedmoor, and I've got profiles for different bullets that I shoot at different speeds. When you click on each of them, it will open all of this information just like the Hornady app. Best thing about AB Quantum is that it has a vast bullet category library, including rimfire and centerfire stuff. So basically anything that you shoot, AB Quantum is likely to have data on it. That includes both G1, G7 and CDM ballistic profiles. This example is a 223 and I'm shooting Sierra 77 grain Match Kings. So I'll scroll down to Sierra, find the 77 grain Match King, and here you can see G1, G7 or CDM. I'm going to click CDM. Scroll down, this is my average velocity I'm gaining through my home loads. The zero range 100, sight height 225. And then just at the bottom with the notes, you can also see you can put different notes in there as well. Just changing the range here so you can see the difference in elevation. And here I'm going into the profile and just changing the ballistic coefficient model just so I can demonstrate to you that you'll get different results depending on which model you use. It's not a massive difference, but the further you go out, the further it will make a difference. So like I said, there's a lot more features in this and I'm not going to have time to go over all of them, but it's just another example of an app that does the same thing. Both of those apps, being fairly simple once you understand them, can be quite complex to newer shooters, but fear not, there is a simpler way. This app is literally just called Ballistics Calculator 2025. This is what the home screen looks like. Again, like the other more complex apps, there's literally just the same things like zero distance, scope height, vertical clip in MOA or mil, bullet weight, muzzle velocity, ballistic coefficient in G1 and G7, and then you've got your environmentals like your wind velocity, your temperature, humidity, pressure, and all those things. And then click on the little graph item, second in from the right. You'll get a table that looks a little bit like this. This will show you your adjustments from your predetermined ranges in the settings. So you can have this increment up in 1, 5, 20, 50, 100, 200, all depends on you. It'll give you pretty much all the data that you'll need to get on paper. You'll drop in MOA or mil, your wind, and this is just a super easy way to do it. I said I'd touch on this later, MOA versus mil, the age-old question. Which one's better? Which one should I use? What is an MOA? What is a mil? I'm going to explain that in the simplest terms I can. Both MOA and mil are angular units of measurements used by shooters to determine scope adjustments and group sizes. MOA, standing for minute of angle, is equal to 1/60th of a degree. This translates to a touch over 1 inch at 100 yards. This extrapolates linearly as distance increases. 1 MOA at 200 yards is 2 inches, 1 MOA at 300 yards is 3 inches, and so on. Mil, on the other hand, uses the metric system. Mil, or MRAD, is short for milliradians. 1 mil is equal to 10 centimeters at 100 meters, and like MOA increases linearly. 1 mil at 200 meters is 20 centimeters, 1 mil at 300 meters is 30 centimeters, and so on. To compare MOA, 1 mil is equal to 3.6 inches at 100 yards. As an example, using both MOA and mil, we are shooting 300 yards and have entered our data into the ballistics calculator, but our shot has landed 6 inches below the 10. What do we do? MOA. We know that 1 MOA at 300 yards is 3 inches, which means 6 inches at 300 yards is equal to 2 MOA. Our scope turrets are 1/4 MOA clicks, so we will adjust up a further 8 clicks equal to 2 MOA. On the same target, converting to mil, we know that at 300 yards, 1 mil is equal to 10.8 inches or 27.5 centimeters. If we are 6 inches low, which is 15.2 centimeters, we will need to come up 0.55 mil. These examples work exactly the same when it comes to wind adjustments, but instead of adjusting up, you adjust against the wind either left or right. In conclusion, neither one is better than the other. They both do the same thing. Pick the one that works better for you and just work with it. MOA is great if you work in inches and yards. Mil is easier for metric shooters and potentially faster for quick math. That's pretty much it really. Like I said, I haven't covered everything in massive detail, but from this video you should be able to grasp the basics by doing a little additional research. Enjoy your shooting, be safe, and don't be afraid to ask questions. Knowledge is power. See you later.